लेट्स स्टार्ट योर स्नैप इंटरव्यू फॉर फाउंडेशन इंजीनियरिंग। आपका इंटरव्यू है आईएसआरओ में साइंटिस्ट पोस्ट के लिए। तो फर्स्ट ऑफ ऑल इंट्रोड्यूस योरसेल्फ।
Morning, everybody. I am Akash Mohan. I have done my BTech and MTech from IIT Kanpur. I was enrolled in a dual degree course, so I got both the degrees at the end of 5 years. After that, I was placed in Shaburji Palonji, which is a leading construction firm in the field of civil engineering. There, I have worked as a deputy manager planning. After that, I have worked in Fit Spaces, which is a interior designing and fit out firm. There, I worked as an operations manager. After that, I have appeared for UPSC where I succeeded in films and qualified for mains 3 times, but couldn't get to the final list. I have good technical and management skills, which comes as a result of my academic background and job experience.
ओके। सो मुझे बताओ कि आप अलाउएबल बीयरिंग प्रेशर के बारे में क्या जानते हो।
Sir, level bearing pressure it is governed by the shear criteria as well as deflection criteria. We have to find the allowable loads from both the criteria, and the minimum of the two should be allowed on the footing.
हाउ विल यू कैलकुलेट दिस लोड फॉर द shear?
For shear, we can use the bearing capacity concepts. Like the Zagi bearing capacity equation. From that, we can get the reliable load which can be applied on the footing.
हाउ?
So for any given footing, depending on its shape and depth, we can find out the bearing capacity, and then based on its area, we can find the ultimate load, and the ultimate load divided by FOS will give the reliable load.
That's the bearing capacity equation
Uh, so for which type of footing, sir? Can we specify whether it is circular or square?
for the rectangular footing.
Yes. So I'm telling the equation. It is 1 plus 0.3 B by L CNC plus gamma DF NQ plus 1 minus 0.2 df by b, 0.5 gamma b and gamma.
Df by b, that is depth of footing, right? It is depth of footing or width of footing or foundation.
Df by b means depth of footing divided by the width of the footing.
So I think this should be the width to length ratio. 1 plus 0.3 b by L CNC
Yes, sir.
plus this Q and Q, that is half of this gamma df, plus this zero point 0.5 b n gamma into this what gamma, and within bracket 1 minus zero point 0.2 b by L. B by
Yes,
L
sir.
is
Yes, sir.
there, na?
False. It should be b by l, sir.
Mm.
Should be b by l. Yes.
So this equation is representing what?
Sir, it represents the ultimate bearing capacity of a rectangular footing using Terzaghi concept.
Hmm. And how you're getting from here the load for the shear failure criterion?
Sir, if any external load is given, so then after this ultimate bearing capacity, we have to find the
No,
net ultimate
we
load.
are not given with the this external load. No, we are going to calculate the this load carrying capacity of the soil. Then what
Okay.
is the role of the external load?
Okay. So in that case, that if you need to find the net external load which can be applied on the footing, so first of all, uh, we have to find the net ultimate bearing capacity, and then based on depending on FOS, we have to find the net safe bearing capacity. This net safe should be equated to the safe bearing capacity of the soil, and from there we can get the allowable load.
Question is same. Whenever you are writing the net ultimate or net say bearing capacity equation, you will find the same parameters. The only thing is that you will not get there the gamma df. The surcharge has been removed.
Yes, sir.
Now, how will you get the pressure or this load for the shear filling criterion?
So this whole equation will be equated to P upon B square, P upon L into B. And then from there we can find the P.
Write the equation, show to me.
So this I have written the Q net safe. That is the net safe pressure intensity. And that should be equals to external load P divided by its area, P upon L into B. And from there we can find the P, which will be the allowable load.
So this load is as per the shear criterion or the settlement criterion?
It's shear criteria, sir.
Shear criteria. Okay. Now, if we have to write with the settlement criterion, then
For that, sir, we have, so I don't remember the formula. That is, I guess there is some Henry Peck formula for settlement. I mean that I
o-
don't know remember the entire procedure for that. I have just done one column on that, but there are some methods like Henry Peck method or something like that for settlement criteria.
okay, tell me the use of the Rankine theory.
So Rankine earth pressure theory. Sir, Rankine theory it helps us to know the lateral pressure which is coming from a backfill. From that we can
In
calculate the
foundation,
okay. Sir, we use the assumptions of Rankine theory in our study of bearing capacities, like the soil is homogeneous and isotropic, or the soil is considered cohesionless, backfill is horizontal, and
can we use Rankine theory for the this writing the bearing capacity of the soil?
yes, sir, we can use that.
Okay. So tell me or write the bearing capacity equation by the Rankine's theory.
It is something like 1 plus sin phi upon 1 minus sin phi multiplied by QU. So I couldn't remember the exact formula, sir. It is something like that. 1 plus sin phi upon 1 minus sin phi divided by area, like that.
1 plus sine phi upon 1 minus sine phi.
And then we have one or two more terms in that.
So write down, I'm telling you. QU equal to, that is the
Yes,
ultimate
sir.
bearing capacity. Gamma DF
Yes, sir.
1 plus sine phi upon 1 minus sine phi whole square.
Yes, sir.
Okay. Now every term you know very well in the equation.
Yes, sir. Yes, sir.
Now tell me, if we are putting the foundation on the ground surface, then what will the ultimate bearing capacity as per the Rankine theory?
It will be zero.
Is it practically possible? Soil doesn't have any this load carrying capacity at its ground surface.
No, sir, it is not possible.
Then you said we are using the Rankine theory. So my question was
Sir,
like that one. What is the use or why we are using the Rankine theory in the foundation? Although we are not using it for the bearing capacity calculation of the soil, because if we are putting the DF equal to 0, then the ultimate bearing capacity of soil coming to be 0. That is not possible. It is not true. Practically we are getting the some value, na?
yes, sir. It is not applicable for surface footing.
It is not applicable for.
Surface footing.
What is the meaning of surface footing?
The footing which is located at the surface ground surface only, and df is zero in that case.
What is the minimum depth of foundation or footing?
So it is the depth at which the bottom of the footing is located from the top from the ground surface.
What is its value as per IS code?
So it will depend on the depth. It will depend on the depth at which we are getting a firm strata.
Suppose you are getting the firm strata at the ground surface. The ground surface is a rocky strata. So you are going to place your foundation on the ground surface.
So if I'm getting a rocky strata at ground only, I can place a footing at ground only. I don't think there should be any problem with that.
Have you ever gone through the codes? We are never putting the foundation on the ground surface. Code is saying big no. Even you are getting the hard strata, rocky strata on the ground surface. The minimum depth of footing is always there. That's why I ask you what is the minimum depth of foundation or footing. What is the this code for the design of this shallow foundation?
I don't know, sir. I couldn't recall right now.
You prepared foundation. You don't go through the codes. What code we are having? Which one code we are following? What you will do in the interview, Akash? They will not ask the question like Viva. You are not sitting in the Viva there, na? They will ask the simple question. They will expect the good answer from you. Okay, the expectation will be very high. So please prepare accordingly. And tell me about this Scampton theory. Any idea about the Scampton theory?
So it is applicable for purely cohesionless soil, and there
Cohesionless
we only
soil or cohesive soil? Scampton
cohesive,
theory.
sorry, sir, cohesive, purely cohesive soil
Hmm.
like clays, and there we only have net ultimate bearing capacity. So QNU is equals to CNC, and NC can be found out as per the shape of the footing.
Is this theory is valid for the both shallow or deep or only for the deep? What do you think?
both for shallow and deep.
Okay. So if you talk about the IS code recommendation for the bearing capacity, so what was the formula for the net ultimate bearing capacity as per the IS code? Okay, the formula that you wrote initially for the rectangular footing, right? Q equal
Yes,
to
sir.
1 plus 0.3 B by L CNC, right? That formula is for what? What type of failure? Local shear failure, punching shear failure, or general shear failure?
So that
What
is for
assume?
general shear failure.
General shear failure. Okay, what is this effect of the groundwater table on the bearing capacity?
So if the groundwater table reaches to the top of the ground, then in that case the bearing capacity will decrease.
Okay, this will decrease. What is the reason for this one?
So because the gamma now will be gamma submerged, and that's why
Mm.
the value will become less.
Mm. Uh, Akash, we have to check the settlement of the soil, and we are going to find the load at which the soil is failing due to the settlement criteria. What test you will do on the soil?
For settlement, we can have plate load test or SPT test.
Okay, plate load test. At what level we are conducting the plate load test?
So ideally, we should conduct it at the level of the foundation.
Mm.
Sir, I want to say that the equations which I wrote at that time, like for the rectangular fitting, it is applicable both for general and local shear. At that time, I told you it is only for general shear. It is both for general as well as local shear. Only the NC, NQ, and N gamma will change if it is a local shear case, depending on the value of phi.
Mm. Right. Okay. So if you talk about this SPT test, standard penetration test, do you have any idea how we are performing this one?
Uh, so this test gives the N value in which a split spoon sampler is driven into ground by applying a weight of 65 kg from a free fall of 750 mm. So the number of blows required to penetrate the soil for for a depth of 300 mm, that is called as N value, and this is done in the interval of 150 mm each. And the initial 150 mm is called as seating drive, that we don't count in our result. The number of blows required for the last 300 mm is called the N value.
What type of sample we are getting from this split spoon sampler?
So we got undisturbed sample.
On what basis you said this is an undisturbed sample?
So because the structural constituent of soil, its moisture content, and the mineral constituent, they are not changing.
How you come to know they were not changing?
So when we are putting a blow on the sampler, uh, the soil sample is getting accumulated inside its depth. So the sample which we will get, that is not getting disturbed anyhow. Although there is some dynamic loading, but the soil which is getting collected, that is inside the tube, which is not getting disturbed.
The question is that how you are this sure the soil is not disturbed. It was in its natural condition what we have in the ground, and same we are getting from this split spoon sampler. How we ensure that?
So we can check the moisture content, or we can check the similarity in the structure and the mineral constituents to confirm that it is the same sample or it is the undisturbed sample.
Okay, my last question to you: have you heard about pressure bulb?
Yes, sir. It is the reason which gets affected due to the load which is applied on any particular structure.
So what type of loading we have?
We can have any line loading or point loading or any area loading. For that, a pressure valve is created depending on the area which get influenced below the ground surface.
What is the application or significance of this pressure bulb?
So it helps us to know that what volume of soil is getting affected due to the applied load, so that we can figure out uh, till what depth or width the soil is getting affected by the load.
So what you will do by knowing that one, this is the volume of soil that is getting affected due to that particular load.
So we have to make sure that the volume of the soil which is within the pressure bulb, it should be of good quality, and we can make sure that there will not be there will not be significant settlement or any kind of failure within that pressure bulb.
Okay, so let me give you feedback, Akash. See, you need a lot of improvement, right? I already told you, work on the points what I told you in the last session also. Pressure bulb. Okay, so you can say pressure bulbs are whenever there is loading. So what we are doing, we are joining the points of equal vertical stress. Equal vertical stress. We are joining the points. The line that we have is nothing but kind of the isobar. You can also say the isobar. Now, what is the application? Why we are just want to know what is the depth of this pressure bulb? It doesn't mean we just want the soil should be safe within that pressure region. It should always be safe. But the main purpose is that if you are putting the two or more foundations close to each other, then this pressure bulb should not be overlapped. Then the region which is overlapping between the two pressure bulb, it will be overstressed, and due to that settlement will take place. In case of the railways, when the sleepers are placed, the spacing of sleepers are decided on the basis of this pressure bulb. This is a significance. And if you are ensuring the soil within the pressure bulb should be of the good quality, we are not replacing the soil. Are we replacing the soil? No.
So in that case, we can change the location of the footing till we get a good soil.
Now suppose alignment is such that the railway track is going and alignment is such that you can't change that particular pier location. Then what to do?
In that case, either we can improve the soil, or also or there is no option.
You can improve the soil or you can just change your design methodology. Suppose you are going with the some like of this pile foundation. So first of pile foundation, you have to go with the ground improvement techniques. After that, you can do the pile foundation, and method of work construction will also be get changed,
Yes, sir.
right? So and what I ask you regarding this Rankine theory, the use of Rankine theory in the foundation part is only to know the minimum depth of foundation. What is the minimum depth of foundation that we are getting? Now we are not using the Rankine theory for the calculation of the ultimate bearing capacity of soil, because when you are putting the foundation on the ground surface, it is coming to be zero. That's practically not true. Now IS 456. This is the Bible for the civil engineering. Na? IS 456. This is a code of practice for the plane and reinforcement concrete work. The footing is of the RCC. Minimum depth of footing is 50 centimeter. You can't put the footing below this distance. Matlab, you can't put the footing on the ground surface. The distance should not be less than the 50 centimeter. At least it should be 50 centimeter or more than 50 centimeter. Minimum depth of footing is what? 0.5 meter. Are you getting? So we are getting the idea from the Rankine theory. If it is coming to be more than this zero point 0.5 meter, then go with that value. If it's coming less than the zero point 0.5 meter, then go with the zero point 0.5 meter, because code is restricting. You can't put your footing on the ground surface.
So the minimum depth is coming from the Rankine theory only.
Minimum, we are using the Rankine theory to know the minimum depth of foundation. This is the only purpose. And what I ask you, how will you get the shear load? That is the load for which soil is feeling shear. Even you don't tell me. I think you don't have the clear idea. So think about on the question first, Akash. So first of all, keep trigger on your brain, sir, we will do the shear test. What we are doing practically, we are conducting the triaxial test are there, usage test are there, DST test are there. You will say, sir, we will take a soil sample, representative soil sample we will take, and we will conduct the test on the that soil sample in the lab. Triaxial test is the most versatile test. So what we are doing, we are getting the C and phi value, na? This cohesion and angle of internal friction. So as you are changing the this moisture condition, C and phi values are getting changed. So on the basis of that, you are telling this is the shear strength of the soil, and according to that, you can calculate the load. What is the load that a soil can bear? And
So
second,
I assume that the SBC of soil is known to us, and here we
no, no,
just
no,
need to
no,
find the external load
no,
what we
no.
can
As
apply.
when we are writing the bearing capacity equation, there are so many parameters. C is there, NC is there, NQ and gamma. NC, NQ, and gamma are the bearing capacity factors. They only depend upon the this angle of internal friction value. C is also there. So that's why I told you keep trigger on your brain, because they will check your presence of brain also. They will not tell you have to tell this and this. They will ask you. They will start asking you, and they will judge what type of answer you are giving to them, how you are analyzing, how you are seeking the condition. If you are taking it in casual way, so definitely you will be out of race. You have to start, sir. We have the shear test, we have the settlement test. Shear test like triaxial test, most versatile test that we have. Even we are doing the DST test also practically. In railway, we are doing the DST to check the this C and phi. We don't have the much time. We are just correlating with the what the C or phi we already have, right? So most of parts you were saying the answer, लेकिन you were lagging. You were lagging. What you have to add?
So in this question, I took it in a wrong way. I just came to know that I just need to find the external load P, and I know all the soil parameters. I know SBC. Just apply the formula and find T.
Let me
This is
tell
what I
you.
take in this case.
Always we are writing the what is the load that soil can take on the unit area.
Yes, sir.
Because if you see the length, soil is infinite in length, soil is infinite in the this width. So our concern is only with the depth now. So if we place the depth of foundation minimum, you told to me this is the minimum depth of footing, sir. Rankine theory we are using, this is giving the idea this should be the minimum depth of footing, although it will depend upon the this what is the external load that we have. And now if we just want to know the ultimate bearing capacity, just see, analyze yourself. If you know the ultimate bearing capacity and you just want to write the area of the foundation, so you can calculate the area of foundation. Ultimate bearing capacity you have, external loading you have, you can calculate that this should be the minimum area of the foundation, plan area. But my question was for the this shear failure. How you will get the soil is failing at this force? So you will simply say, sir, we have the shear test, settlement test, like we have the plate load test. In plate load test, the soil is failing due to the excessive settlement. Na?
Yes, sir.
You have to add these things in your answer part. That was missing.
It's a,
Okay.
the speed test gives us a disturbed sample or undisturbed sample.
Yes. Generally, in the SPT test, you can get the both type of the this sample, disturbed or undisturbed. We get the both, but be careful whenever they are asking what type of sample you are getting. So first of all, say, sir, although sample are disturbed or undisturbed, it will depend upon the this thickness of the sampler. If the thickness of sampler is more, then definitely we are getting the disturbed soil sample. If the thickness is less, then we are getting the undisturbed soil sample. Now there is one term is there, area ratio. If the area ratio is less than 10%, undisturbed soil sample we are getting. Are you getting? We have the cutter there, inside thickness is there, outside
Yes, sir.
this
Inside
width
clearance,
is there.
outside clearance.
Inside clearance, outside clearance is the right word. So on the basis of that, first of all, you have to introduce that one. It means you have the crystal clear idea on the basis of what we are saying. This is a disturbed, this is the undisturbed soil sample. Don't look into the bushes. If you look into the bushes, definitely you will get into trouble.
Sorry, sir. Don't look into the.
Don't seek answer into the bushes. Are you getting what I'm trying to say? If you have clear idea, then you can directly go. Otherwise, you can say, sir, right now I'm not able to recall it. But I think if you prepare only the foundation part, please go through these things. Anything else?
Uh, so I have a question that how should I prepare in so much depth? Because like in foundation or any other subject, I'm just going to the basics. Foundation, I
See,
just went to the types of footing, shallow foundation, deep foundation, and
you
what
have
is net
idea.
resistance, all the
You
basic
have
things I got.
idea and you have technical skills also. That I judge. You know the things. Now the major thing is that always listen question very carefully. What is being asked from you, and always keep with the paper and pen. Whenever you're answering, just write okay, this thing. And you can go through the snaps available on the session. Panel के ऊपर बहुत सारे snap पड़े हुए हैं foundation के, soil के, right? You can go through them directly. What type of questions is being asked by the mentors, or even we recorded the experiences also, na? So do the smart work. You have the this work experience also. You have very good academic background also. You did a master's from IIT, na?
Yes, sir.
Mm. So expectation will be high. In the very first session, I told you, expectation will be high from you. So just analyze what is the requirement. First, go with all the basic terminology, because I ask you what is the use of the Rankine theory in the foundation. You don't have idea. If they are asking the design, that is a we can say that was a kind of the high level question, because you were not a designer. You were not a designer. So if you are doing the mistake, that it is okay. If you are writing an equation and you are getting some mistake in the equation, that will be adjustable. But if you're lagging in the basic question, I think that will be very harmful. I didn't ask any design question from you. I didn't ask you the cutoff length. How will you frame the cutoff length? I didn't ask you a question like that. I didn't ask any design question from you. I didn't ask the IS6403, that is a code for the shallow foundation for the bearing capacity as per the Indian standard code. I was just simply asking the very simple questions. Now just do one thing, at least focus on the foundation part में भी shallow deep foundation दोनों देखे जाओ, टेस्ट जरूर देखे जाओ, सॉइल के ऊपर जितने भी टेस्ट हैं कोई भी टेस्ट मत छोड़ना, जितने भी टेस्ट हैं एक बार जरूर गो थ्रू कर लो। सबसे बड़ी बात उनकी एप्लीकेशन ध्यान रखना। टेस्ट का प्रोसीजर भूल भी जाओ, डजेंट मैटर, लेकिन एप्लीकेशन पता होनी चाहिए कि वो टेस्ट कहाँ पे यूज करते हैं, क्या हम उस टेस्ट को यूज कर भी रहे हैं इंडिया में आज की डेट में, ये भी ध्यान रखना। बुकिश नॉलेज इज नॉट सफिशिएंट, यू हैव टू अपडेट विद द व्हाट वी आर डूइंग इन द कंट्री आल्सो। कौन सा नया कोई हम प्रोजेक्ट कर रहे हैं, कोई नया हमें अभी चैलेंज मिला, सो प्लीज रेडी विद दैट वन आल्सो। वर्क करना पड़ेगा आकाश, यू हैव टाइम, दिन रात एक कर लो। इफ यू वांट टू ज्वाइन द ISRO, देन यू हैव टू डू वर्क। काम करना पड़ेगा, स्मार्टली काम करना, डेफिनेटली सक्सेस विल बी।